What's up, YouTube? I got a tutorial video for you for Unity's new input system. The way you install it: Window, Package Manager. You want to make sure you're checking the Unity registry. Type in input or just scroll down till you find input system. Doesn't matter the version for this video. Click install. Mine already is installed, of course. And once it's finished installing, it's going to ask you to restart Unity to essentially enable it as your input system and disable the old one. At any time, you can go Edit, Project Settings, and in Player on the left, you're looking for Other Settings. Scroll down until you find Configuration, Active Input Handling, and you can check the new system or the old system or have both at the same time. So that's nice, you can do both. I'm going to make a very basic platformer. Move left, move right, jump, fall off the cliff. And the point of today's video is I want to go through all the different behaviors of the input system, all the different ways that you can have it tell your script that input is being had. So let's go ahead and create our C# script for the player, which in my case, for the purposes of this video, is going to be Go Sagan. And we're going to make very basic platformer script. So let's get some variables for move speed and the like. Oops, should probably finish typing that. Float move speed. I'll initialize that at 8. Serialize field, another float for jump force, initialized at 25. Then we've got a rigid body, so a rigid body 2D, which I am going to call my rigid body. And I've got a box collider, so box collider 2D, that I'm going to call my box collider. You won't necessarily need the box collider, but I'm using it for detecting that I'm on the ground. And we're going to need a vector 2 called input vector. In our start method, we're going to want to get our various components here. So I'm going to say my rigid body equals get component of type rigid body 2D. And I'm going to say my collider. Oh, I guess I named it my box collider equals get component of type, you guessed it, box collider 2D. You can use any collider, don't worry about specifically copying squares like me. In our update method, we are going to call our move method, which we haven't made yet, don't worry about that. Our jump method is going to call itself, because the new input system makes that a bit easier to just send the input to the script, and the script just says, aha, I got an input, jump. Let's make a move method, and the move method is going to be, I'm just going to do transform.translate for the movement. I'm not going to use the rigid body for that. So this is going to be a vector 2, a vector 2 called, we'll call this movement delta equals new vector 2. And we're not touching the y axis on our movement, just the x. So we want input vector dot x and multiply that by, of course, our move speed, and multiply that by time dot delta time. And then on the y-axis, just 0, because we're not moving on the y-axis. Then just transform dot translate our movement delta. Hey, one. So that'll be the move method. Then void jump. And this one's going to be called directly through input, but we want to make sure we're on the ground. The way we're going to do that is we're going to say if, and my box collider dot is touching layers, pass in layer mask dot get mask and then a string reference to the layer. So the way we would handle this one, all of our ground, I have on the layer ground, which you just go add layer. You have as many as you want. Type in ground, then go back to the ground itself and put it on the ground layer. So if my collider is touching anything on the layer ground, then, and our jump method is going to be simply my rigid body dot velocity equals new vector 2, and we're not touching the x component. However, this is changing velocity, not adding velocity. So we want to set our x velocity to whatever our current x velocity is. So my rigid body dot velocity dot x, comma, and for our y velocity, we want our jump force. Okay, we're jumping. Everything's set up once we receive inputs for us to move and for us to jump. One last thing we'll need before we actually get the inputs is you need to be using Unity Engine dot input system. You have to be using this to use the new inputs or they don't work. So back into Unity. We haven't made the input system yet. The way we're going to do this, you go into your player, whatever game object you have that you want to receive inputs on, and you add input, player input. Doesn't matter if it's the player or not, that's just the name of the component. You see actions, it has none for input actions asset, and that's the asset that tells the object, in this case the player, what inputs to receive. One way to make it, you can right click, create, and all the way at the bottom is input actions, or you can just click create actions. It'll ask you where you want to save it and what you want to call it. I'm going to call this actions go Sagan. And save, and it will automatically drop it in that action slot for you. And it pops up this menu. Autosave is not on by default, so just make sure either you turn it on or remember to save. Now we're doing two things. We're moving and jumping with the player. So the action maps basically is just, it's like a file system. We're currently in the player file. The player file contains these input folders. The UI file contains these. You can see down here it's got default map player. So yeah, we're leaving it on player. We're not trying to ask anything about the UI. We have move, we need to make jump. So we make a new action, call it jump, and there's no bindings by default. It's got some default move bindings. And the number one improvement that this new input system brings, the number one reason to use it, is the input that your script sees is just move. Your script doesn't see any of this. All of this goes into move, and move talks to your script. So literally when it comes time to play the game, an input coming from a gamepad or a controller is seen the exact same way as an input coming from a keyboard, which makes cross-platform programming so much easier because you don't need to tell your script multiple inputs. You just tell your input actions multiple inputs, and it tells the script the same thing anyways. So for jump, you click on the no binding, you tell it which control scheme you're adding this to, so we're going to do keyboard and mouse. Path just means the binding itself, so you click down. You can go and scroll through and find them, or you can click listen, touch whatever key you want, so I just click my space bar, it shows up, boom. Click this little plus, add another binding, click the binding, this one we want on gamepad. Click this, listen, touch a button on my controller, boom, okay. We're ready to receive inputs. Now the point of this video is this behavior right here. There's 4 different behaviors. There's send messages, there's broadcast messages, there's invoke Unity events, and there's invoke C# events. Send messages and broadcast messages are probably the easier of the two. Invoke Unity events and C# events have some terrible naming conventions, but are a bit more powerful. We're going to go through all of them so that whatever you're trying to do, you'll know how to tell your code that you got the input you're looking for. And you can see send messages has a list below with all the messages. So there's on move, on look, on fire. Happy thoughts? And the way this one works is anytime that it gets one of the inputs, it's going to go to all the objects that have this labeled as their input actions. So our player input script has the actions. This one's dragged in that box. So it's going to go to all the instances of this, and then it's going to call every component on this object and just say on move and send the movement input. And our player script will pick that up, which we haven't even put on the player yet, so we should probably do that. Boop. Our player script will pick that up and be like, aha, I'll do something on move, I'll do something on jump, so let's head into C# and make that happen. So it's as simple as typing void, not ubun, on move, and the variable that it passes along is called an input value, which I'll just call value as our input. And what do we want to do when we receive movement value? Well, we want to take our input vector and make it equal to the value dot get. And what do we want to get? Well, if we open up this, our movement, you can see returns a vector 2, and jump is just returning a button. So jump can be up, jump can be down. Movement can be any vector 2 of magnitude 1, which without a control stick, you're not going to be able to make too many of those, but so it's get, oops, vector 2, and that's going to set our input vector equal, well, to our input vector, and we're done. We can move. Now for jump, void on jump. This one's also, when you're doing send messages, they are returning input values, which I'll call value again. For this one, we don't need to know specifically what the value is. We just need to know that the value is there. So if, and there's not that many options for input value, value dot, which one do you think it is pressed. If value is pressed, jump. And why is it not happy about that? Jump could not be found? Are you missing a U? Did I mess something up here? Did I misspell something? Jump. What? It auto-completed jump. Why is it? I typed is instead of if. Oh my god. What? Okay. Save. Back into Unity. This should be working. I don't know why the red squiggly was in the wrong spot there. So our player script does indeed have player input and the player script. Hey, bun. And we're moving. One down. So that is send messages completed. And again, when you're using send messages, all the various options for messages to send will be here. Next up is broadcast messages, and the difference between send messages and broadcast messages is that broadcast messages is going to send that message not just to your game object, but also the children of that game object. So we're just going to create empty. We'll call this mom. Just like real life, mom is empty. We'll make us a child. Player input, add that to mom, drop our input in there. And then we take ourselves and can remove the player input completely. So let's just remove component. And you can see right now this is on send messages. We don't need to do anything else here. If it broadcasts the message and we hear it, we already have the script for those inputs. So let's click play. And right now on send messages, click buttons, nothing happening. Change to broadcast messages, and we're moving. That is 2 down, and I'm sure people are going to ask in the comments, so let's just answer it ahead of time. Create another empty. Let's get grandma in here. Reset the transform. Mom, get rid of that component. Grandma, add component. Player input. Drag in the thing. And you can indeed see, we'll leave it on send messages just to demonstrate pushing buttons. Nothing happening. Broadcast messages, and we can move. It does indeed go down the chain of children. Okay, let's get these old folks out of here. That is 2 down. See you, Mom. See you, Grandma. Let's get our player input component back on the player. What? Am I crazy? Did it just disappear? Player input. That was weird. That was weird. No, what? What is going on? Unity, why are you so strange? Okay. I have an idea. Rather than try to drag, we're going to click the nozzle and select the thing. Take that. Okay, we did send messages, we did broadcast messages. Now we're going to invoke Unity events, and this one's a little different. It's not returning input value as its variable. If you click down events and player, you'll see here's our move, our look, our fire, and our jump. We're just doing move and jump. It's not sending input value, it's sending callback context, the dumbest name that anyone thought of in a while, maybe since Elon Musk's son. Here he's got a few. So the way this one works, let's, we don't need these anymore. I'll leave them there in case someone wants to reference, but we can comment, we can comment those out. The way this one works is you've got to add your methods to the list, and it'll say, whenever you give an input for move, it'll send the callback context of that input, and we'll explain what that means, don't worry. It'll send it to those methods. So we want our jump method to get input action dot callback context, which we'll just call context, as a variable, so that when we click jump, it'll call jump. We also want another method, which I'll just call set movement vector. And this one also wants the input action dot callback context as an argument, and we will also call this one context. And what this one's going to do is it's going to set our input vector equals, and when we were doing this one for an input value, it was value dot get vector 2. This one is context dot read value, and then the same vector 2. I don't know why they're different. To me, that is so strange that they made this new input system and we have input values and input action dot callback context rather than just like what? Why are they different? I don't know. Not going to pretend to know. So for this one, we want to get specifically the vector 2, whether the button, and remember there's three different times it'll send input. If it was just pressed, if it is pressed currently, or if it was just let go of this frame. For this one, we don't care which one we got for setting the movement vector. Whichever one we got, we want to set the movement vector to that. But for jump, we want to know if it was just pressed this turn. So we put if context dot, and there's three possibilities. There's canceled, means it was just let go of this frame immediately. Performed means that it is down this frame. And started is the one we're looking for, means that it was pressed down for the first, or not for the first time, but it's that this frame it was pressed down and last frame it wasn't, essentially. So that we just pushed the button. So if context dot started, then jump. And let's reformat a bit to look pretty, and go away. If context.started, then do our jump. And let's save that up. Hopefully I haven't botched anything. And then there is one last thing. I have, in fact, botched something. The one last thing to do, we need to add one to move. And the way you do this, you click the plus, you drag in the object that you want to send the object that has the method that you want to send input to. So we want one on move and one on jump. And you'll notice when we go into select the function that my functions aren't there, and that's because I forgot to make this a public void jump and a public void set movement vector. Kudos if anyone noticed ahead of time. So we'll give that a second to compile. We'll scroll down again, which is really fun. Then now we have set movement vector for move, and we have jump for jump, and that should be that. We should be moving and jumping. Move, move, move. Jump, jump, jump. 3 down. Okay. The last one on the list is a bit unique. Invoke C Events. And the reason why it's unique, you don't need the player input component on anything at all. So you just remove component, screw off. And here's the reason why I didn't want to put any spaces in the name of our input action. So you go to this asset, the thing that brings this up down here in your assets, and in the inspector you'll see generate C# class. So this is how it's going to invoke C# events. You click the check mark. You don't need to worry about these. That's just the name and where it's being saved. Click apply. It'll create a C# script in the same file that it's in. You don't need to look at this script at all, but we're going to need to know the name of it, which is actions go Sagan in our case. So we can go ahead and close it. We do need a reference to it. So how about below our vector to input vector, we're going to go actions go Sagan, and I've got a really unique name, actions go Sagan. Then we're going to need to need to get a reference to this. We're not going to do it in start though, because these input actions they're a bit picky. It's a bit weird. They're a bit picky. We're going to do it in void on enable. So when the object gets enabled, which happens just after awake. And we're going to tell it actions go Sagan equals new actions go Sagan. And essentially what that means is now we've told our code, once this compiles, we've told our code, create ourselves one of these. But it's not quite one of these, it's an empty one of these. We haven't told it that these player and UI are active. We haven't told it what inputs we're looking for. So we don't care about UI, we care about the player portion. So we tell it actions go Sagan, lowercase, ours in particular, dot player dot enable. And we want to do the method, not the bool, capital E enable, call the method. And here's another annoying thing is anytime you enable something for the new input system using Invoke C# events, you gotta disable it. So on disable, we gotta go actions go Sagan dot player dot disable. Are we ready yet? No, we're not ready yet. There's still a bit more prep. So we'll go back into our script for a second. I really shouldn't be saving yet. So there's move, look, fire, and jump. We don't care about look and fire, but we want move and jump. So actions go Sagan dot player dot move, and we need to tell it a script to put the move inputs into, but there's 3 different contexts to move inputs, There's you just pressed the key, which is started. There's the key is currently pressed at all, whether this frame or otherwise, or whether it was first pressed this frame or if it just is still pressed this frame, that's performed. And then there's the key was just released is canceled. So for the move command, we want to know every frame if it's pressed, and we want to know if we've let go of move. So we don't care about started, but we do want move.performed. So that means it's down at all. And we now have to tell it which function that is looking for callback context. We've got two of them. We need to tell it which function to send this to. So the way we do that is we say plus equals, and then in this case, set movement vector. And I know normally you call a function every time you type it, but you're not calling this function. Just put a semicolon. You're telling it this goes here. That's all you're telling it. So we need performed. We also need actions go Sagan.player.move.canceled. So that's now if we've taken our finger off the button, and that goes in the same one. And again, anything that you subscribe to on enable, you must then unsubscribe, unless it's my YouTube channel, then you can stay subscribed. So minus equals, and make sure you do those before calling disable. So we've got our movement ready, and then for jump, it's going to be actions.goSagan.player.jump. And then we don't really care for performed. We want to know if we just pressed it this turn. So that's not canceled. That's not performed. That's started. And we can just tell that plus equals jump. And then I'm not going to implement a partial jump, but I can show you what the inputs would look like if you were going to do that. So that would be something along the lines of actions go Sagan.player.jump.canceled. So you push the button, it jumps. Doesn't care if you're holding the button, but it'll notice when you let go of the jump button, and then that'll also go in jump. And the way that would look if you're trying to implement a partial jump, so up here we've got public void jump, and we don't need to change any of this. It's still the same callback context is what we're getting from this. So that's just feeding in here the same way it was for Invoke Unity events. These are both already working. But if you wanted to have partial jump, you would have something along the lines of if context.canceled and implement partial jump here. So however it is that you'd want to remove some jump speed. Yeah, you know what, while we're here, why not? Okay, my rigid body dot velocity equals new. We'll do a very crude implementation. So we don't care about the x component, so velocity.x can just be set to velocity.x, and the velocity box collider, my rigid body dot velocity dot y will just multiply by 0.5. Fun. That's sort of a crude way to do partial jump. For some, inside the parentheses, for some purposes this works. For some purposes you'd want something more sophisticated, but just a basic idea. If you want to implement partial jump, this input is where you would do it. Okay, and the last thing, if you subscribe to anything other than my YouTube channel, you must also unsubscribe. So minus equals, save that up. Lots of tedium, but the big benefit from this is you don't get extra input calls that you won't use. So if you're holding down the spacebar ready to let go for a partial jump, you're not wasting input calls every frame on the game telling the script, You're holding down the spacebar this frame. You're holding down the spacebar this frame. Did you know you're holding down the spacebar this frame? It's just not even telling you. It doesn't waste any performance on those calls. It's only if you pressed it this frame or if you let go of it this frame. So it does help a bit. Okay, bun. This is it. And we're moving. Nice. So, brief recap. Send messages is the one where you're calling on move, on jump, and the variable that you pass in is an input value. Same for broadcast messages. And then invoke Unity events and invoke C# events are ones where you're passing in callback context. Anyways, that's going to be it for me. Peace.